Okay, example 5. Everything equals 0. Okay, this is, the book calls it a homogeneous equation. I don't know why, but that's what they call it. Homogeneous. Okay. If nothing else works, 0, 0, 0 is the correct answer to this. In other words, if you get to a point where it's an empty set situation, or two of the planes are parallel, whatever, 0, 0, 0 is going to work. Alright? With that in mind, what I want to do is I want to eliminate a variable like usual. I want to get rid of y, get rid of z, get rid of x, doesn't matter which one. To me it looks like y is pretty easy. The bottom two equations, the y's cancel right off the bat. So 2x plus 3x is 5x. Negative y plus y cancels. Z minus 2z is negative z equals 0. And then if I take the top equation with the middle equation, doubling the middle equation. So 2 times 2x, 4x plus x is 5x. 2y minus 2y cancels. 2z minus 3z is negative z is equal to 0. And this is what we're hoping for here to get a C answer. We get the exact same equation. Right. So that represents a situation where we got an answer more than just 0, 0, 0. We're going to get a C answer out of this. Now, once I've gotten rid of y, I'm left with just x's and z's. So I want to get C as equal to x or z. Here's my way of picking. There's no like, this is the right way to do it. The last one didn't matter because the last one said x minus y equaled 6. They're both 1x and 1y, right? So it didn't matter. If you have coefficients, let x equal that number. Or I should say c equal that number. So x has a coefficient of 5, z has a 1 coefficient. Let x equal c. Alright, so if x equals c, I go back to either one of these equations in the same equation. 5x, which is c now, minus z, we don't know yet, is equal to 0. Move the z to the other side, all of a sudden 5c is equal to z. If I'd gone the other route with that and let z equal c, notice 5x minus c is equal to 0. 5x equals c, all of a sudden x equals c over 5, all of a sudden we get a fraction. So if you let c be the variable that has a non-1 coefficient in front of it, you're going to get fewer fractions in your answers, easier to deal with. It doesn't matter, they're both correct. X equals c, z equals 5c, or z equals c, x equals c over 5. Same relationship. Okay, so x is c, z is 5c. The only thing we don't know is y. I go back to one of my original equations. I'm going to take the bottom one here. It says 3x. We're letting x equal c, so that's 3c. We don't know what y is yet. Minus 2z. Z is 5c. 5c times 2 is going to be minus 10c. Which gets me y minus 7c is equal to 0, so y is equal to 7c. Again, that's the correct answer. The book really likes fraction answers on these, so if you're checking your answer in the back of the book, I mean, if you do that pick instead, do the opposite of what you want to do, you get a fraction answer, you're more likely to get what the book gets. But again, if you just want to randomly check an answer, c equals 37. 37, just some random number. 37. 7 times 37, 9, carry the 4, 259, 37 times 5, 165, that's right. 37 times 5, 185? Maybe 37 wasn't the best choice. But if I put 37, 259, 185 into all three of those equations, are all going to be true. I'll let you guys believe me on that. Let's pick a smaller number. This one. That one will work, but I just don't want to do it. Let's say c equals 9. 9, 63, 45. Alright, so 9, 63 times 2 is 126. 3 times 45 is 135. 135 minus 135 is 0. 2 times 9 is 18. Minus 63 plus 45 for that one. 63 minus 63 is 0. 3 times 9, 27 plus y, 63. Minus 2z, that would be minus 90. 90 minus 90 is 0. It works out. Okay? So again, if you aren't sure your answer is right, pick a C, create the order triple based on the value of C, verify this works, which means that this has to work and that's the right answer.